Okay, so let's begin today's class with organic chemistry. The first topic is inductive, which I will not record it today. Sorry for the inconvenience actually. I have a work at home, that's why I'm going. If we are going to talking about carbon single bond carbon, then this is 1.54 angstrom. If we are going talking about carbon double bond carbon, this is 1.34 angstrom. And if we are going talking about carbon triple bond carbon, this is 1.2 angstrom. But whenever we experiment on benzene, we got the bond length is 1.39 angstrom, which in between the carbon single bond carbon, which is 1.54 angstrom, and carbon double bond carbon, which is 1.34 angstrom. Okay, now we got to know that all the resonance structures are equally important, and I can say all the resonance structures are equal, but they are not real, they are hypothetical, their real existence is not possible. But if we are talking about the resonance hybrid which is possible, that it has the real existence. Okay. Next, if we are talking about the single structure cannot explain our all properties of molecule, this is called as resonating structure. Next, resonating structure is also called as Kekule structure or conical structure, or I can say हाँ इतना ही. तो अब if we are talking about carbon, so carbon have, if there is a positive charge on carbon, then it prescribes, it shows, but it tells about its vacant place. So if we are talking about the electronic configuration of carbon, which is 1s2, 2s2 and 2p2, and if there is a positive charge, then there will definitely a vacant place present. Okay. And if you know, there are 4 orbitals and 3 orbitals which is in bonding, but 1 orbital is there which is in vacant. Okay. Next, we are talking about how to detect resonance, is there is resonance or not, how do you know that, how to know about that. So there are 3 types. First, we are going to discuss the first type is if there is double bond, if there is single bond, if there is empty orbital, and the second is if there is double bond, if there is single bond, and if there is lone pair, and the third is if there is double bond and single bond and free radical. If it describes the orbital like this, if it describes the orbital like this, and nothing is here, it means it shows that there is empty orbital. If there is an I can say like this present, then this is your lone pair, and if there is only one present, this means this is your electron. So in electron they are present only a free in free radical they are present only a electron. In lone pair there is 2 opposite pairs, and in free orbital there is nothing present. Okay. There is a trick which is if we have an example like CH2 double bond, CH single bond, CH2, then first naming the bonding first 1, 2 and 3, and the trick says ki if there is a bond between 1 and 2, then transforms the bond of 1 and 2 towards the 2 and 3, and the positive charge which is at 3 transforms it towards the end of 1. Like I can say, if there is an example CH2 double bond CH single bond CH3, here is a positive charge, then the I can say, then the trick is say he transform the 1 and 2 bond, this bond towards, first naming this 1, 2 and 3, then transform this bond towards this side and transform this towards this side. So this is says about the I can say this is says about the resonance structure. So this is the trick is going on. Okay. Now if we are talking about the second trick, if there is an double bond single star and a lone pair, then the trick is going very same, and there can be two resonating structure, 3 resonating structure, 1 resonating structure, 4, 5 infinite of resonating structure is possible there. And the type 4, which is the like conjugation. If there is double single double single double bond are present there, then it tells us about the conjugation. And if there is back bonding, which is there is free orbital are present, then the electron can be shared between them. This process is known as back bonding, and while the back bonding, the bond is formed which is called as back bond. Okay. Now, if we are going to talking about stability of resonating structures, so the first is stability rules is more the pi bond, more is the stability. It tells that if there are two electrons which have a greater number of pi electrons, then it says that uh, the structure which has high number of pi electron, I can say pi bond, is more stable as compared to other. And if we have two I can say if I have two structure which from which one is neutral and one is charged, then we can find the neutral is much more stable than the charged. The third rule says that if we have two structure, then opposite charge if closer to each other, then it says more stable. And if the I can say opposite charge will very less, I can say very larger distance between them, then this says to be less stable. I can say it if same charge are very close to each other, then this is called to be less stable. And if they are very far apart from each other, then this process is called as more stable. Then I can say negative charge on more electronegative atom is more stable, and positive charge on less electronegative atom is more stable. Now, if we have same pi bond, same charge, and same negative charge on same atom, then this resonating structure is called to be equivalent. Sorry, जो actually गला में खराब है इसलिए कोई नहीं. Then this process is called to be if what we are talking about equivalence resonance. If there is same charge, same pi bond, and same negative charge on same atom, okay, the negative charge on same atom, then the then the two structures are called to be equivalent resonance, and equivalent resonance is much more stable than other. If we have extend and cross conjugation, so extend conjugation which is focused in one direction, and cross conjugation which can be done by two direction. So if we are talking about the stability between them, then the I can say the cross conjugation is less stable than the extended conjugations. Now, if we are going to talking about the how many type of resonances there are so many resonances, but today's class we are going to talking about only one resonance, which is plus R or plus M resonance. If we are talking about electron donating group, the M is the mesomeric effect. Okay. So if there is if we are talking about this, so there is increase in density. I can say electron density increases in ortho and para positions. So ortho and para positions, so I can say in ortho and para position there is increase in density, but there is no effect on I can say meta positions. So if I am talking about how do you able to see me, do you able to show me the ortho, para and meta position? I can say ortho, meta and para positions. You see this diagram and tell me. If I have like benzene like this, and I have like this, then we have to see, we have to show what is the meaning of alpha, ortho, meta and para. Just to see कि this part is your group is attached. Then if you are talking about this part, then the very simple, this part is your ortho, this part is your ortho, this part is your metta and this part is also your metta. And if you are talking about the this part is your if you're talking about the para positions, this is this part which is opposite towards this part is the para positions. Here again del negative, here del negative, here del negative, here del negative is present. Oh sorry, here not del negative is present. यहाँ पर कोई del negative नहीं होगा यहाँ पर. तो ये वाला और ये वाला इस तरीके से अफेक्ट करता है. देयर इज नो इफेक्ट ऑन मेटा पोजिशंस इन दिस इफेक्ट. ओके. Now, how do we how do we detect the plus pair and plus n? So, the lone pair containing compounds, all lone pair containing compounds are called as a plus R or plus M group. So, I can say the if there is any kind of lone pair containing group, a lone pair, uh, the group which has lone pair, this group is in plus R and plus M. This is for today. Thank you so much. I hope you enjoyed the class. I hope I am able to tell you all the concepts which is necessary to work this exam. बाकी मिलते हैं नेक्स्ट क्लास में. तब तक के लिए थैंक यू सो मच. And the next topic which we are going to start is minus R and minus M effect, which is another very important chapter. Important topic of resonance. Still, take care of yourself, take care of your family. Happy learning, keep learning, keep practicing.